Hi students, how are you all? I hope you are all fine and safe at home. This is K. Venkatesan from Department of Physics, Bharathidhasanar Matric Higher Secondary School, Arakkonam. Now I am going to introduce a new topic, Capacitor, from 12th standard Physics, first unit, Electrostatics. See, Capacitor is a charge storage device and electrical energy storage device. The simple capacitor is consist of two metal plates. This one is one metal plate, is another one metal plate. Two metal plates separated by a small distance. In this system consists of capacitor. Not only that, the simple capacitor is consist of two parallel metal plates connected with the battery. Now battery voltage V. Now, one plate becomes negatively charged, another one plate becomes positively charged when the battery is connected to the two parallel plates. Here, the battery voltage increases. In this battery voltage increases, the charge stored between the plates also increases. See, this is a very important point. The battery voltage directly proportional to the charge stored in the capacitor. Battery voltage gradually increases, charge stored in between the capacitor also increases. Okay, this is the internal structure of capacitor. This is a simple capacitor consists of two metal plates separated by some distance. Okay, this is a very important term. See, let us two parallel plates separated by a small distance. See, two metal plates separated by a small distance, which means D. So, in these two metal plates connected with the battery, now the electrons are transferred from one plate to another plate. See here, electrons are transferred from one plate to another plate. In this plate becomes negatively charged, in this plate becomes positively charged. The electrons are transferred from one plate to another plate. That time some of the charges are stored in between the plates. The potential of the battery voltage or potential difference or potential of the battery voltage increases, charge stored in between the plates also increases. See, this is the internal structure. Here, the charge stored in the capacitor is proportional to the potential difference between the plates. See, this is the one plate, this one is another one plate. Two parallel plates connected with some battery. Here positive charge, here negative charge accumulated, separated by a small distance D. See here, the charge stored in the capacitor is proportional to the potential difference between the plates. Here battery voltage increases, charge stored in the capacitors also increases. Okay, so general expression, the charge stored in the capacitor Q directly proportional to the potential difference between the plates. So in other words, we are calling Q directly proportional V. In this directly proportional neglected means that time introduce a new terms which means constant term. This is called C. Here Q directly proportional to V. Constant terms you want to apply when the directly proportional neglected means introduce one constant term Q equal to CV. Here CV, C is nothing but proportionality constant or capacitance of the capacitor, capacitance of the capacitor. So general expression, charge stored in the capacitor Q equal to capacitance of the capacitor and potential difference between the two plates. See, Q equal to C into V. The next one is, we need C only, no, C equal to, take C equal to, what is the value? Q by V. This is the capacitance of the capacitor. Capacitance of the capacitor C equal to Q by V. We need volt means Q by C. Just rearrange the formula. Okay. This is a very familiar equation. The capacitance of the capacitor C equal to Q by V. Now, in our study materials, you want to discuss the study material. This is two more question. Define capacitance of the capacitor. The capacitance of the capacitor is nothing but, see, the capacitance of the capacitor is defined as the ratio of the magnitude of charge stored in either plates to the potential difference between the plates. Potential difference between the plates. In other words, we are calling C equal to Q by V. The capacitance of the capacitor equal to charge stored in the either plates divided by potential difference between the two plates. This is very important 2 mark question. Discuss the study material. Okay. Next one is the SI unit of capacitance is, say my dear students, Arun, say what is the value of SI unit of charge? Yes, coulomb. Here coulomb. Unit of charge coulomb. Rahul, what is the unit of potential difference? Yes, SI unit of potential difference. Yes, volt. Here the SI unit of capacitance is charge coulomb divided by volt. So coulomb per volt, the unit of capacitance of the capacitor. Okay, yes. The next one is SI unit of capacitance coulomb per volt, we know that. In other words, they are calling 1 farad, honor of Michael Faraday. Is Michael Faraday? The SI unit of capacitance is Michael Faraday, means farad, but farad is a large unit of capacitance. But nowadays we are using the smallest unit of capacitance, see, microfarad or picofarad. 1 microfarad, the equivalent value, see, 10 power 6 farad. 1 micro is nothing but 10 power minus 6. So farad. So 1 microfarad equal to 10 power minus 6 farad. 1 picofarad equal to 1 pico, what is the value? 10 power minus 12 pico value. So nowadays we are using this type of capacitor only. Okay. See, the next one is symbol of capacitor. This is the basic symbol of capacitor. Fixed capacitor, 2 metal plate separated by a small distance. See, 2 metal plates. This one is 1 metal plate. This one is another metal plate. 2 metal plate separated by a small distance. Small distance D. Okay. So this is the fixed capacitor. The next one is polarized capacitor. Positive ions and negative ions separation, no. This one is polarized capacitors. The next one is variable capacitor. We need 20 microfarad or 100 microfarad or 1000 microfarad. We need no. That time at that time we are using variable capacitor only. Okay, this is the variable capacitor. This is the symbol of capacitor. Keep your mind. Okay, next one is various type of capacitor. Nowadays we are using various shape and size of capacitor. The first one is cylindrical type and the another one is disc type. Okay, this is the type of capacitor. Say cylindrical type, disc type. Okay, nowadays we are using this type of capacitor only. So next one is capacitance of a parallel plate capacitor. This is very important 5 mark question. Capacitance of a parallel plate capacitor. Say, what is the definition for capacitor? Capacitor is a charge storage device and also electrical energy storage device. What is the formula for capacitance? We know that general formula for capacitance, C equal to Q by V. This is the capacitance of the capacitor. Okay, but now I am going to discuss or introduce another one topic, capacitance of a parallel plate capacitor. Okay, sir. The capacitance of the parallel plate capacitor is nothing but, let us consider here 2 parallel plates or 2 conducting plate. This is the one plate represents letter A, another one metal plate B. 2 parallel plates separated by a small distance. Separated by a small distance D. Here given D. 2 parallel plate separated by small distance D. In this 2 parallel plate connected with the battery terminal voltage. Connected with the battery terminal voltage. Okay. Now area of cross section of the 2 metal plate is A. Here given area of cross section A. Okay. Now in this 2 parallel plate separated by a small distance, area of cross section A and charge density, sir. Charge density is nothing but sigma equal to Q by A. Sigma equal to Q by A. This is another expression we will discuss later. Okay. So next one is the electric field between due to infinite parallel plate is uniform. in this equation from application of Gauss law. Okay, see the electric field between the two parallel plate, we need electric field between two parallel plate E equal to sigma by epsilon 0 in this equation from according to Gauss law. Okay, according to Gauss law, equation number 1. Okay, sir. The next one is sigma is nothing but surface charge density. Here minus q charge, here plus q charge. This is a surface charge density. In other words, we are writing the surface charge density sigma equal to what is the value? Charge per area. This is equation number 2. Okay. Substituting this value in above equation, sigma value, we will get the answer E equal to electric field E equal to sigma value Q by A into epsilon 0 into epsilon 0. This is the electric field between the two parallel plates. Okay, electric field between the two parallel plate E equal to sigma by A epsilon naught. Okay, sir. Now, potential difference between the two plates. How much, sir? Potential difference. Potential difference represent letter. Say potential difference between the two plates. We know. So that only. Now finding the value of potential difference between the two plates V equal to general expression E into D. Okay. This is equation number 4. Here E is nothing but uniform electric field. D is nothing but the two parallel plates separated by a distance D. Okay. See, this is the V equal to E into D. E value already we know that. What is the E value? E equal to Q by A epsilon naught. Substituting this value here, we will get the answer B equal to same. E equal to what is the value? Q by A epsilon naught. A epsilon naught into here D only. So equation number 5. Okay. This is the potential difference between the two parallel plates. The next one is finally we need capacitance of the parallel plate capacitor. What is the formula for capacitance of the parallel plate capacitor? That only now finding the answer. No. See, C equal to general expression capacitance of the capacitor Q equal to C equal to Q by V. Already V value we know that. Substituting this V value here in this value. C equal to what is the value? Q by sigma. V value, substituting this here, V value Q D by here, Q D by A epsilon 0, A epsilon 0. Here Q cancel, rearrange the above equation, we will get the answer. What is the value? C equal to A epsilon 0 into D. This is the final equation, the capacitance of the parallel plate capacitor. See, capacitance of the parallel plate capacitor is C equal to what is the value? C equal to A epsilon D. C equal to A epsilon divided by D. This is the very familiar equation. Okay, this is the capacitance of the parallel plate capacitor. Okay, the next one is. See, capacitors are widely used in many electronic and electrical devices. So, in this section, in this next section we will discuss application of the capacitor. Okay, is a very huge uses of capacitor. We will discuss next class. So, next one is concept question. We know that capacitance of the capacitor formula, So, basic concept question, NEET and IIT. See, concept question, see here. A parallel plate capacitor has square plates of side 5 cm and separated by a distance 1 mm. Okay. The next one is first question. Calculate the capacitance of this capacitor. First question. The next one is, if a 10 volt battery is connected to the capacitor, what is the charge stored in any one of the plate? This is the second question. Here given data, epsilon 0 value constant term 8.854 into 10 power minus 12 C Newton meter square Coulomb power minus 2. This is the constant value given data. So solve this problem. See here. First question. The parallel plate capacitor has square plates of side. See, let us consider here parallel plate. This is the parallel plate. Separated by distance. How much? Distance given? No. 1 millimeter. Here 1 millimeter. Connected with the battery terminal voltage. Next given data, area of cross section is given. This metal plate area of cross section A equal to what is the value? Square means square plates of size 5 centimeter. So 1 centimeter equivalent value 10 power minus 2 meter whole square. So A is given. Okay. So D is given and A is given. These are given data. D equal to 1 millimeter. See 1 millimeter equal to what value? 1 millimeter equal to 10 power minus 3 meter. 1 milli. Okay. So 1 milli equal to 1 into 10 power minus 3 meter. Area of cross section A equal to square 5 into 5 25 into 10 power minus 4 meter, which means meter square. So this is the given data. So first question, the capacitance of the capacitor, the general expression we know that C equal to what is the value? Epsilon 0 A divided by D. Substituting this to all the value, we will get the answer. C equal to epsilon 0 value. What is the epsilon 0? Here epsilon 0 value here 8.85 into 10 power minus 12 into here A value, area of cross section 25 into 10 power minus 4. Okay. So divided by what is the value? D. D value 1 into 10 power minus 3. 1 into 10 power minus 3. Here minus 4 minus 3 cancel, remaining here 1. So minus 2 minus 1 minus 12 minus 1 minus 13. So C equal to 8.85 into 10 power minus 13. Okay. So into 25. So multiply these two value, we will get the answer 221.2 into 10 power minus 13. So what is the unit of capacitance? Farad. Now convert microfarad means picofarad. So change that value. C equal to 22.12 into 10 power minus 12 farad. So 10 power minus 12 is nothing but pico value, no? So substituting this value, C equal to 22.12 picofarad. This is the capacitance of the capacitor, parallel plate capacitor. Answer. Okay. So next one is, next question. If a 10 volt battery is connected to the capacitor, 10 volt battery, here asking the question, charge stored in any one of the plates. What is the form of charge stored in the capacitor? We know that C equal to Q by V. We need Q only, no? So rearrange the formula. C. Next question. The charge stored in any one of the plate is Q equal to CV. We know the general expression. General expression means capacitance of the capacitor C equal to Q by B. So rearrange the equation. We need Q only, no? So Q equal to CV. See here given data already V value 10 volt. Okay. The next one is C value. Final equation, capacitance of capacitor 22.12 into 10 power minus 12 farad means picofarad, no? So substituting these two value in above equation, we will get the answer Q equal to C value 10 into 22.12 into 10 power minus 12 farad. Okay. So charge, see farad. Next is charge, unit of charge coulomb. We know that. Here Q equal to multiply 22.12 into 10. So 2 to 1.2 into 10 power minus 12 coulomb. So we know that this equation 10 power minus 12 pico value. So substituting this value, answer Q equal to 2 to yes 2 to 1.2 pico coulomb. This is the answer, second answer. Okay, pico coulomb. Okay, second question answer. The charge stored in any one of the plate is Q equal to 2 to 1.2 pico farad. 1 pico equivalent value 10 power minus 12. Okay, so next. Okay, my dear students, below this video we have attached PPT YouTubing study material. Okay, so if any doubt means contact us. Thank you.